All right, thank you very much. It's really an honor and a pleasure for me to introduce our next speaker, Vicky DeGlugo-Kecke. But I've known Vicky now for 8 years, and I got to know Vicky through the National Shipbuilding Research Program, the NSRP, which I'm sure she's going to give you a little bit more information on. It's basically a Navy-funded consortium for helping to maintain the competitiveness of our naval shipyards within the United States. So Vicky's been an engineering and management consultant in shipyards and shipbuilding and ship construction for the last 15 years. Prior to that, she held numerous positions at various shipyards, in addition to working at the American Bureau of Shipbuilding, which is an organization that develops rules for ship design as well as monitoring the quality of the ship design and construction. She is currently a Society of Naval Architecture and Marine Engineering Fellow. She's a member of the National Council of American Society of Naval Engineers. She's on the editorial board of the Marine Technology Publication, which is the standard magazine for the SNAME organization, and she's the vice president of the Webb Institute Alumni Association. Today, Vicky's going to talk about a project that we're working on together, which is focused on implementing Auros workflows in 4 different large and mid-tier shipyards. And I have to tell you that she has been invaluable to our efforts. Pardon the pun, but she's been a boatload of information for us. She has provided us, she's our translator. So coming from automotive and trying to deal with shipbuilding, she has to explain to us what the heck we're looking at and reading and understanding the concepts. So we really appreciate it. And as I said, she's been invaluable. And so, Vicky?
So that Greg really built me up. I hope that I can. I hope I can live up to my hype. So I'm here to discuss this knowledge provisioning to improve first-time quality and ship design project that we started with the National Shipbuilding Research Program. The project only kicked off a couple of months ago. So I'm only going to be giving you a few highlights of what we've done so far and what we're planning to do. So the guys from Auros and IKAA haven't paid me to say this, but be sure to come back next year so we can talk about all our successes from this project, because it's just a year-long project to start. So come on back. Oh, click. 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 Oh, no. All right. There we go. Oh, that was my first slide. So what I'm going to talk a little bit about today is, because I don't think a lot of you here are shipbuilders or ship designers, so I'm going to kind of just give you a quick overview of shipping and ship design and shipbuilding. I'll give another quick overview of what the National Shipbuilding Research Program is. Greg alluded to it. It's a way for the Navy and industry to collaborate, including funding collaboration to promote cost savings within Navy and commercial shipbuilding programs. I'll give you Greg again alluded to our project team members. So we've got 4 shipyards on the project team. We've got numerous other members on the project team. I'll kind of go into a little bit about each one of those and kind of what they do and what their roles are on the project. And then I'll eventually go into what our NSRP project is. Like I said, we've only kicked off recently, so there's not too much to talk about, but I'll give you the highlights of what we've done so far and what we're planning on doing. So shipping and ship design, oh, shoot. I gotta remember to do this. Okay, there we go. So shipping and ship design and shipbuilding. So it's a global industry. I don't know how many of you know this, but more than 90% of U.S. imports and exports are carried by ships. People know, they know about tankers. There's container ships that carry 40 or 50 foot, the containers you see going on the road, those 53-foot containers, those are all carried on ships across the ocean from our trading partners. There's bulk carriers, they carry coal, things like that. Roll-on, roll-off ships, I'll show you a couple of those. They actually, instead of just carrying containers, they bring the whole truck on board, and they have a ramp, and they roll on and roll off. We have our U.S. Navy. There's probably about 400 plus in the Navy fleet. That includes active service vessels and reserve. We have about at least 270 part of the battle force. Our combat fleet includes the aircraft carriers, submarines, guided missile cruisers, destroyers, frigates, amphibious ships that carry the Marines and all the Marines equipment. There's a whole bunch of, so then that's your combat ships, but then there's got to be a whole fleet of ships that take care of those combat ships because they go out for months on end, and so they have to be supplied with fuel and ammunition and food. So there's auxiliary oilers, there's ammunition carriers and storage carriers, and then there's a whole slew of other ships that are in the Navy, survey and oceanographic ships, mine countermeasure ships, little patrol craft that can go just about anywhere. U.S. is building ferries and passenger vessels. We don't really build any of those giant cruise ships here, but we do have little cruise ships that we build. I gotta make sure I do this. And there's also a big fleet of research vessels, fishing vessels, tugs, dredges, things like that. So now, I'm gonna ask for the poll. So my poll is, I'm going to ask you guys, how many different ships and ship types do you think that I've worked on in my career? I've been in the marine industry since 1984. So that's just a preview. I see what the answers are coming in as. What I'm going to do is I'm going to pull like The Voice or America's Got Talent, and I'm not going to tell you the answer until I go through the next few slides. Things are going, all right. Oh, see, the first few people thought I was a lot older than I am. Obviously, most people think I did more than 20 ships in my life. I guess since I've been around since 1984, that's probably true. So, here's some of the ships that I've personally done some work on. Whether it was while they were being constructed or while they're being designed. These 4 ships, all the 4 ships on this page, I actually worked on even before I graduated college. So I worked on the aircraft carrier at Newport News. I was an outside machinist. I carried around a wrench that had to be about this big, and I would be tightening bolts on the Teddy Roosevelt. This is a DDG 51. They're still building those. We're up to DDG 117, 118, so that was a very successful ship class. They've been through 3 different flight upgrades, so it's not the same ship as it was in the 1980s when I was busy designing it. These are FFG 7s, so those are the fast frigates. They were on the end of their building career when I was working on them, and this is a tanker that I worked on where I went to school, a part of our co-op type program. They actually put us on board a ship for a couple of months to teach you all the things that you shouldn't be doing when you're designing ships. This is one of my first jobs. I worked on 9 of these different Del Monte reefer carriers. I affectionately called them the banana boats. They have cargo holds full of fans that blow cold air all over crates of bananas and guavas and whatever they're growing in Costa Rica and Guatemala. I put on condition-based maintenance system and a planned maintenance system, computer system on these ships, and that was in the early 90s. They were doing that back then. Here's the Exxon Valdez. So I graduated right around the time when the Exxon Valdez hit Bly Reef. And I was on the legal team for the case, and I was actually on the side of Exxon. So I had some very interesting analyses that we've done. You can talk to me at lunch about all the analyses I did, but let me tell you this. If they would have called a different rudder angle, or if they would have found out 5 minutes earlier or 5 minutes later, it wouldn't have happened. From the analysis. Last night I sat next to someone who was in the Gulf War. This is how we get our ships over to, if you need ships somewhere, this is how we get them over there. They put ships on top of ships. So the ship kind of sinks down, you can see it right here, and then all the other ships kind of float onto it. And right now, the Navy's actually building some more of these because we usually have to charter them from somewhere else. You know, when we had those accidents in the Pacific, we usually charter someone else's heavy lift ships to do this work, to bring ships over. So we're building some of our own right now. This ugly little ship is my pride and joy. It's 4 different versions of it. I was the head naval architect. This is called TAKE. It's an underway replenishment ship. I like to say that it carries ice cream and chicken nuggets to the fleet, but it carries a lot more than that. The fleet stays out, and this ship shuttles back and forth between the port and the ships, and then they, and then they transfer fuel. This is fuel being transferred back and forth between the ships. This is an aircraft carrier. They're shooting over a line to transfer fuel. Here's a hospital ship that they're transferring over stores. So the shipyard built 14 of those. Here's a roll-on, roll-off ship that transports, at the time, about 50% of the stuff that goes up to Alaska gets transported up on 2 of these ships. And it's owned by Totem Ocean Trailer Express. If you remember, during Hurricane Joaquin, there was that tote ship lost down off Bermuda-ish. That was the same owner. And this is a 1.3 million barrel tanker for British Petroleum. Oops. Page down. So those were all big ships. I worked with big shipyards. So I also work with little shipyards too. Oops, I'm supposed to be pointing up here. I'm busy pointing at there. Here's a Coast Guard cutter. It's the smallest of the new Coast Guard cutters. Here's a suction dredge that you have to make sure that they don't suck up turtles in turtle nesting areas. So it's they're allowed to suck up the sand, but not the turtles. These ships go back and forth to the oil rigs, offshore supply boats, and tugs. And here's one of those. Oops, that way. And here's one of those newest heavy lift ships. You can see here, they're kind of loading LCACs, the air cushion vehicles, up onto one of those ships. Oh, here it is too. So, the answer was, I've worked on more than 70 ships in my short career. I counted, and I came up with 82, but I'm sure I missed a few here and there. So the maritime industry, we've got broad reach. We have ship designers and engineers. We have shipbuilders. Some of these ships are around for 30, 40, 50 years, so maintenance and repair are big, so we have a lot of big ship repairs. There's the ship owners, ship operators, ship management, and then there's the whole other side of the industry. We've got port authorities and terminals, part of the marine industry. There's the Navy, the Coast Guard, other government vessels. There's the regulatory side of the industry, so the shipbuilding industry regulates itself. They write their own rules and regulations. I'll talk a little bit, and one of our team members does that. I'll go ahead and talk a little bit about them later. There's marine insurance, marine finance and law, and then all of the manufacturers, suppliers, and distributors that supply things that are put onto the ships to build them. So now, we said it was the National Shipbuilding Research Program is sponsoring our project for knowledge management. I wanted to go a little bit into what they do. So the NSRP, their mission, they get funding through the Navy, and they figure out what technologies and processes that they want to spend this money on. So it's a competitive environment. Shipyards put in proposals, and then the NSRP selects which ones they think are going to be the best for the industry. They want to reduce total ownership costs for the ship, so it's not necessarily just acquisition cost, but maintenance and operating costs too. And we've got the different shipyards that are part of that consortium are both commercial and Navy shipyards, so they want to try and leverage the best commercial and naval shipbuilding practices for the whole U.S. shipbuilding industry. It's a collaborative environment, so we don't really talk about, so the shipyards get together and they don't talk about costs, they just talk about best practices and processes, and it allows them to share ideas. So the NSRP Collaboration, there's 12 member shipyards within the national, and these are the shipyards that make up the Executive Control Board. So any shipyard can participate in a National Shipbuilding Research Project, but these are the 12 shipyard members that kind of lead the program. One of the shipyards, our lead shipyard, which is Conrad Industries, are missing off the map. And then for you, I'm sure there's some engineers here, so they're busy counting. So Vigor has since dropped off. So there's 12 pictures on there. They're missing one, and one's dropped off. So what the NSRP focuses on, most of their money is spent on research and development projects. There's big projects, research announcement projects, that can go into the millions of dollars that usually last a year or two. And then they do some small, and those projects all require, the government will give you money, and then the shipyard puts up half the money. So it's cost sharing between the government and the shipyards to better their processes. We have, I say we, but I'm not a member, I'm not part of NSRP, I'm just me. But the NSRP has panel meetings, so there's a bunch of different panels, they have panel meetings, they have conferences, all with the purpose of sharing the R&D results that the different shipyards get, so the other shipyards can learn from them. And then there's some other ad hoc initiatives that they do. Some of the examples of that is they do some benchmarking between U.S. shipyards and foreign shipyards. There's right now a commonality initiative where we're trying to use some common processes, parts, standards across the different shipyards, ship designs. And there's also, we talked about Greg mentioned, Society of Naval Architects and Marine Engineers. There's a NSRP SNAME working group that's kind of I said we just kind of do our own rules and regulations. SNAME has some guidelines that we use for different parts of the ship design, so we're kind of NSRP is helping update those. So it's divided into major initiative teams. There's a ship design and materials technology team and focus area. There's ship production technologies focus area, business processes and information technologies focus area. Then there's the infrastructure and support focus area for NSRP. That's kind of how it kind of breaks out. Oops, page down. So I mentioned how we're doing this knowledge provisioning for first-time quality in shipbuilding. Our team members on that project, we've got Conrad Shipyards, who are the leader of the project. We've got Bollinger Shipyards, which was a team member. Fink and Terry Marinette Marine Shipyard. General Dynamics Bath Iron Works, and General Dynamics NASCO are all team members. We've got our technology providers. Auros, of course, is one of them. Ship Constructor, which is SSI, is a team member. I know that Pat David is here somewhere. There he is. So they are part of the project. American Bureau of Shipping. They write rules and regulations for ship design, and they have standards for construction and then also for survey and operations while the ships are in operations. There's my name on the bottom, and we also have Hepistol Consulting Group that are kind of consultants to it's kind of the translators of shipbuilding to the Auros guys. So Conrad Shipyard. It's been around since 1948. They've got 5 shipyards in Morgan City and Amelia, Louisiana. If you look across the river from the shipyard, they've actually filmed Naked and Afraid there. So when you go down there, you got to watch out for alligators, and you got to watch out for bugs that are bigger than your head. They've done they've finished more than 1,000 vessels since they were established for all types of commercial and government owners. One of the key ones here, which is kind of new to the marine industry, are these LNG bunker barges. So shipping has kind of taken to LNG as a fuel. So now we need a way to get LNG onto the ships. So we know how to get fuel oil onto ships, but now we've got a new cog in the supply chain for LNG. Bath Iron Works, right from their website. Shipbuilding has been a way of life in Bath, Maine for many, many years. We've got 2 representatives from Bath Shipyard here with us today. They're here to hear about, obviously, how you guys are implementing Auros, so find them out at lunch. And for those who haven't, or just in the beginning stages, kind of like we are, still find them out, and you might have similar questions. So Bath was started out in the early 1800s. It became a shipyard in 1884. They've been around a long time. General Dynamics was busy buying up shipyards in the mid-90s and acquired them in 1995. They've got more than 425 ships, including 245 military ships. Now, most of their ships that they do are military ships. I don't think you guys are doing any more yachts and commercial ships, unfortunately. Marinette Marine. Oh, I should really be telling you what those pictures are, but anyway, those are that's okay. Marinette Marine are close here. They're in Marinette, Wisconsin. They've been around since 1942. Fink and Terry, who are the Italian shipbuilders, Andrea, wherever you are, came and bought them, and with a bunch of other shipyards here in the United States in 2009. And they've actually designed and built more than 1,500 vessels for military and commercial customers. General Dynamics NASCO, I was their supervisor of initial design and naval architecture there before I became a consultant. They were established in 1960. They've got one big new construction yard in San Diego. and 3 ship repair yards on the east and west coasts. They're the largest full-service shipyard on the West Coast, and they're one of the few, they're definitely the only big U.S. shipyard, and one of the few U.S. shipyards in general that are successful in building both commercial and Navy ships at the same time, even though their naval ships are a little bit simpler because they're only Navy auxiliaries and they're not really designed for shooting and being shot at. So they do tankers, they're doing container ships, roll-on, roll-off, container ro-ro ships, and then the expeditionary sea base and transfer dock. That's the one. That's the transfer dock that sinks down. And Bollinger Shipyard, unfortunately, has kind of dropped off the team, but they've. I neglected to say that there was a small panel project that Auros was involved in. That's kind of how I actually found out a little bit about Auros before then, and Bollinger was a key team member on that project. We'll keep going, since they're not on the team anymore. So Ship Constructor is a 3D a 3D product modeling software that was birthed only for the shipbuilding industry. There's hundreds of users in North America. There's hundreds of more users around the world. It's used for both commercial and Navy ship design, and it's used from small design shops to big, large enterprise clients like the big Navy shipyards. They've done all different types of ships have been designed with Ship Constructor, and I think Pat told me it was started about 15 years ago. American Bureau of Shipping. So I talked about how the shipbuilding industry kind of regulates themselves. They regulate themselves through what they call classification societies. American Bureau of Shipping is one of them. They were established in 1882. There's more than 50 of these classification societies worldwide. 12 of the biggest ones are members of the International Society of Classification Society. More than 90% of the world's ships are covered under the rule sets of one of these IACS members. The largest classification societies are American Bureau of Shipping, DNV, which is Dernesky Veritas, and Germanische Lloyd. So those were the Dutch and the Germans kind of got together. Class NK are the Japanese. Lloyd's Register is in the UK. RENA is the Italian class society, and BV is Bureau Veritas. They're the French class society. But it's not, they're competitive worldwide. So if you're a Japanese shipbuilder, you might be using ABS rules. It's kind of, you go and some class societies have more experience at different types of ships, so you kind of shop your class societies based on what kind of ships you're doing. So what do the classification societies do? They promote safety of life and property in the environment through engineering standards for design, construction, and maintenance of the ships. They do ships, they do offshore units and other marine-related facilities. And the different engineering, these different standards are comprised in rules established by each of the individual societies. They're busy now trying to harmonize some of those rules so that they're the same across class societies. Then we have project facilitators to kind of introduce the guys from Auros into shipbuilding. I am one of them. And Lisa Heppenstall from Heppenstall Consulting Group is another one. We've both been in the marine industry for many, many years and have been consultants for the past 12 or 15 years. And we both have worked almost exclusively for shipyards in our consulting lives. And we've also, Lisa and I have worked numerous projects together through NSRP. So, finally, the NSRP project. So, when we presented this project to shipyards and to the NSRP, we said, what's the problem? And we say we're losing our technical know-how in the shipbuilding and ship repair industry. And by no means do we mean that we're not doing a good job, because some of the brightest engineers and designers, planners are busy building ships, world-class ships that travel throughout the world. But we need to get better at it. I talked about how NSRP does some benchmarking, ad hoc stuff. So FMI is a company that they hired to do that because they've got a standard way that they do it. They did a benchmarking study for NSRP in 2004. What they found was we're getting increasingly complex vessels, and that there's no indication that this is going to stop anytime soon. I was just talking with Pablo at the break, and all we were talking about was windshields on cars. And so you think that that's kind of simple. But now that's where they're embedding all your sensors and stuff like that. So they get more and more complex every time, every step we turn. And ships are no different. So what FMI also found was there was need to rationalize design standard approaches that included new methods and reducing design costs. The CNO, which is the Chief of Naval Operations, had their strategic plan come out in 2016, which is probably right around the time when we were writing the proposal for this project. And it almost sounded as if they wrote it so that we could propose an Auros project. They wanted to apply best concepts and techniques to accelerate learning for individuals, teams, and organizations. They wanted to make sure we're not relearning old lessons. I heard a lot of conversations. I've been part of conversations these past 2 days where people are talking about lessons learned. Shipbuilding is no different. We have plenty of lessons learned, and we don't necessarily always learn them. But we have tools to capture them. We just have to make sure that those lessons get pulled back into the design. And the CNO also says that during the execution of ship designs, they want to do routine and rigorous self-assessments. So once you read that, you put it together with Auros, and now we have a project for shipyards and shipbuilding and the Navy to learn about knowledge provisioning. We talk about complexity in ship design and shipbuilding. One of the big dimensions of complexity involves the increased number of parts within product lines over time. I'm not really quite sure where we got this graphic from, and I know that there's plenty of people here from the auto industry and probably from land vehicles and aircraft also, so tell me if these numbers are wrong. So now the blue curve represents the 1980s, the green curve represents where we are today, and you can see that complexity and number of parts have exponentially grown. So we say that in the 1980s, automobiles might have had around 3,000 parts, land vehicles 14,000, aircraft, fighter jets maybe 30,000, big airplanes, 747s, over 100,000 parts. Ships, in the 1980s, there were probably anywhere between 1 and 6 million parts on a ship. Today, that ranges anywhere between 3 and 10 million parts per ship. So you can see our mission is huge. The objective of our project is to automate the provisioning of information and knowledge to each step of the ship design process as the engineer progresses through the flow of work. So we heard from Jeff, making that knowledge from passive to active. And that's what the project's there for. We're following the standard Auros practice. We are converting the shipyard technical memory into different K-packs. We've also got a separate task where we're looking at industry standards, which will be incorporated into K-packs. Then we kind of jump down to the bottom before I go to the middle one. And that's then integrating it into the shipyard's workflow and preparing the knowledge delivery system for the shipyards. As many of you must know, Auros has connectors to different CAD tools. One of the key CAD tools we use in ship design is our ship constructor. So we're building a connector between ship constructor and Auros. The gentleman here from Bath, one of their pilots, they use CATIA. So there's already a connector for CATIA, and they are busy piloting that connector. So the way we've laid out our tasks, we follow Auros' standard process, which they've got in there. They've got workflows and K-packs and everything for it. So we've already performed our shipyard readiness activities. We've figured out what each one of the shipyards are going to pilot. They're busy I said they're busy developing the connector, but Auros and Ship Constructor have users groups, users conferences at the same time. So Ship Constructor is here supporting the Auros, and then on tomorrow night, the guys from Auros fly down to Mobile and are going to demo the connector between Auros and Ship Constructor at the Ship Constructor users group. Right now, we're busy developing and importing the shipyard data requirements, rules, best practices for different individual pilots. Obviously, ship design is a complex process, so there's a lot of different things we can be focusing on, and we've focused different pilots, which I'll go through. We're going to create dashboards. So Andre talked about how they like their team boards. So we're busy talking with the shipyards to figure out what their shipyard dashboards are going to be like. We will test and evaluate the functionality of each of the knowledge packets. And then starting in another month or two, we will implement the different shipyard pilots, let them go for a few months, kind of do our cost benefits and measure the effectiveness, and then prepare our plan forward for Auros implementation. So some of the shipyard pilot focus areas, we're looking at facility capabilities. So one of the shipyards wants to know, can I build this in this shop? So they'll go ahead and they've got a table of all the different shop constraints, and it will, whatever we will build this is, will go and be checked against the shop constraints to see if you can build something there. We're looking at structural design, both functional design and detailed design. We're looking at, we're starting off slow. We're looking at building barges, designing barges. It's a little simplified, but not necessarily too much simplified. We're looking at piping system design, both the functional design and the detailed design. So when I say detailed design, that's kind of the 3D product modeling and using the connector. And then our shipyards are also looking at specific smaller pilots of penetrations and penetration management and allowable areas for penetrations. I know that the guys from Auros always tell us, start at your pain points. And two of the shipyards, so we've kind of two of the shipyards selected penetrations as their pain point, and I can tell you that penetrations and penetration management are a pain point for all shipyards everywhere. What we're also doing is, so we've got a lot of different guidelines and rules and that are used throughout the shipbuilding industry. So we're kind of preparing an industry collaborative starter kit. So there's no shipyard proprietary knowledge. So all the shipyards are using their own proprietary knowledge in their own pilots. But this starter kit is kind of a set of K-Packs that when another shipyard wants to come and try and do an Auros pilot, they will already have some things to choose from in some of their issue areas. So there's NSRP guidelines for penetrations, for design for production. We've got design for maintainability guidelines, distortion control best practices. We're using industry standards, so we've talked about ABS, and we're busy coming up with easy ways to try and import ABS rules into the Auros knowledge packets. We're looking at ABS rules for structural design, for piping and systems design. We're looking at ergonomic guidelines, ergonomic guideline K-Packs, focusing on ladderways, walkways, clearances. I don't know if we use ASTM F1166. I don't know if that's marine or standard. I don't know if that's only marine. I don't know if you guys use it, but it's ergonomic guidelines. ABS has their own version, which are very similar. I talked about how SNAME has technical and research bulletins that provide guidelines for a lot of different engineering disciplines. We're looking at lean design for concept development and pulling in K-Packs for that. There's many other SNAME T&R bulletins that that we don't have time or money to do now, but there's for ventilation guidelines. There's a lot of different things that we can do for that. So, I told you that we just started a couple of months ago. The shipyards are well on their way. They've defined all their pilots. We're well on our way to collecting the information, developing the K-Packs, looking at the workflows, developing assessments. Our Auros facilitators, what are those guys called? What are the Kurtz and the Shawns called? Application engineers. They're doing an excellent job. I'm amazed. They're amazed that I know what I'm talking about, and I'm amazed at what they can do. So our ultimate project goals, we want to reduce non-value added time. We talk about the bookshelves and searching. I thought it was very telling when Steve talked about searching for 1.8 hours a day for information. I can easily attest that sounds like it could very easily be a number I've searched, the amount of time I've searched for things. Improve first-time quality. My work at ABS back many years ago was on engineering quality side, so improving engineering quality is always one of the near and dear to my heart. Simplifying the design review process. So we've got very complex review processes because we've got not only the shipyard's got to kind of review it internally for themselves, but they've got to pass all the Navy, and there's multiple Navy stakeholder reviews. So we've got a very rigorous design review processes that hopefully can be simplified through assessments, knowledge exchange, reinforced standard processes. I think we heard that from Andrea this morning. And our ultimate project goal is to measure usage and compliance and come up with a good business case to hopefully move forward in our next steps. I got 17 seconds left. Any questions?
So I assume in your industry that standards and guidelines do change and evolve. So how do you plan on keeping Auros up to date when those change?
Okay, so there's one of the with our team member, American Bureau of Shipping, one of the reasons we wanted to come up with a way to automatically import their rules and regulations was one of the shipyards said, listen, exactly that. How do I know that this rule from 2016 hasn't changed from the 2018 rule set of American Bureau of Shipping? Usually you get a hard copy of this book of rules or PDF, and everything that's different or new is highlighted in red. So that's obviously not necessarily a good way to do things. So the guys at Auros and ABS are working together to try and figure out, and that's just for ABS, that's just for tracking ABS rule changes between different years. A lot of the shipyards are all ISO 9000 certified, so that kind of requires you to review your processes and guidelines I think it's every 3 years. I don't know if they actually check you, but they should all have processes in place to review to make sure that they're good. But we haven't figured out the way yet of how we're going to make sure that as part of that review, your KPACs get updated as necessary. I'm assuming that the whole KPAC vitality is going to help us in figuring out which things are being used and good, as opposed to which things might be stale and not needed anymore. But we still have to. We're still in our infancy, so that's just something that we're going to have to think about and deal with. I know I'm standing between you and lunch, so maybe that's why there's no questions. I guess that's it. Come back next year. Hear about our results.